Hi everyone, welcome to Coding with Jazz. So today, the coding problem that we'll be looking at is squares of a sorted array. So for this question, you're given a sorted array in a non-decreasing order, and your task is to square all of the elements and then return it in a non-decreasing order as well. So the hard part of this question is you don't know if you're given an array with negative numbers, because if you're given negative numbers, we can't just simply square everything and then return it. We need to basically resort it after squaring it. The most intuitive way of doing this problem is basically squaring everything and then sort it. And for that solution, the runtime is going to be big O of n log n, because for squaring, for sorting, it's going to be big O of n log n. So can we do better than that? The answer is yes. Since the given array is sorted, even with negative numbers, we are certain that the leftmost number after squaring is going to be the largest number of all the negative numbers. And the rightmost number after squaring is also going to be the largest number among all the non-negative numbers. So that being said, we could definitely use 2 pointers to solve this problem. So basically, what we need to do is to have one pointer called left, pointing at the leftmost element in the array, and then another pointer called right, pointing at the rightmost element. And we're going to go inwards. So every time when we look at these two numbers, what we're going to do is compare the square of these two numbers. Say if you're looking at -4 and 10, we're going to compare -4 squared with 10 squared, which is 16 and 100. And we're going to pick the larger one and then insert it into the answers array, which is a separate array that we store the answers. And for the answers array, we're going to insert each element from the rightmost, so from the largest point. And then we're going to move our right pointer inward by 1, because we've already stored that number 100 into the answers array, so we don't need to look at it anymore. So we move our right pointer inwards and then compare those two numbers, the numbers at left pointer and the number at right pointer, square them and then compare them again. And then we repeat until left pointer and right pointer meet, and that's when we have compared all the numbers and have inserted them into the answers array. And now let's move on to actually coding the solution out. So the first thing we need to do is to make sure that the list, the given array is valid. So we need to check if not A or length A is equal to 0, then we simply just return an empty list. And then we need to compute our answers array, and we could initialize it with a bunch of zeros and give it the same length as the given array. And then we're going to compute our left pointer and our right pointer. So left is going to start from index 0, and then right is going to start from length A minus 1. And then what we need to do is to loop through, or use the 2 pointers to move inwards on the given array. So while left is less than or equal to right. Remember, we don't stop until the 2 pointers are crossed, because when they're equal to each other, that's when we're looking at our last element, and that's when we insert the last element into the array. So while left is less than or equal to right, we need to compute the left square. So we get the element at the left pointer and multiply it by itself. And we compute the right square. get the element at the right pointer, and then square that by itself. So now we have the two numbers squared. We just need to compare them and decide which one to put into the answers array. So that being said, we also need another pointer sort of thing, which is call it the insert location. And it's going to start from the end of the answers array. So it's going to be the same as right. So if left square is less than or equal to right square, then we pick the larger one and then insert it into our answers array. In this case, the larger one is the right square. So we put answer equals insert lock equals right square. And then we need to move our right pointer inwards by 1. So right is equal to minus equal 1. And then we also need to move our insert lock inwards by 1. And then else, which is when the left square is greater than the right square, we just put the left square at the insert lock location. And then we move our left pointer inwards by 1, so plus equal 1. And then we also move our insert lock by 1. So then we just simply need to return our answers array. And let's run the code. And voila. Hit submit. And we're done. So let's now think about the runtime and the space complexity of this coding solution. Like we talked about, if you're just simply squaring everything and then sort it, it's going to be big O of n log n runtime because sorting it takes n log n. But now we're not sorting it any longer, so basically the whole runtime is just running through every element and then comparing them. So the runtime is going to be big O of n. And for the space complexity, since we're storing our answer in a separate array which has the same size of the given array, the space complexity is also going to be big O of n. All right, that completes our video for squares of a sorted array, and I hope you enjoyed it. And please let me know if you found a better solution. If you just want to chat, just leave a comment below, and I hope to see you in the next video. Bye.